Okay guys, today I'm gonna do the first principle, how to differentiate using first principle. Remember, we were differentiating using the rule. So the first principle, the formula goes like this: is f of prime x is equals to the f of x plus h minus the f of x divided by h. And bear in mind that I forgot to put the limit here. The limit when h approaches 0. Okay, but I will rewrite the formula correctly when I'm doing the example. So basically this is the formula that we use when we differentiate using first principle. So I'm just gonna give a simple example. If I'm saying differentiate f of x, and then I give you f of x as x squared using first principle. So I'm gonna go to the formula. F of prime x is equals to the limit when h approaches 0, and f of x plus h minus f of x all over h. So how do we use the formula? You keep the lim when h approaches 0. Then this part, what does this part mean? Basically this part means go to the original f function. Wherever there is x, you replace it with the x plus h. And then this part means just subtract the original f of x. So I'm going to the original formula. The original formula is x squared. So just go to the f, and then wherever there is wherever there is x, you replace it with x plus h. So that's this part. And then minus the original x squared all over h. The important part here is the top part. You must be able to substitute the top part, which is this part, the fx plus h, and subtracting the original. This part I don't think is difficult. You're just subtracting the original. And if this function had more than one term, I will have to put brackets here so that when I break the negative, you'll be able to break it into two terms. But since this is a one term, it doesn't matter whether you put a bracket or not. Okay, let's continue. The limit when h approaches 0. Please bear in mind that you must always keep this limit until you are substituting this h that we are saying is approaching 0. So simplifying this part will be x squared plus xh plus h squared. I'm using the shortcut here even. So if you don't understand the shortcut, you can go further and try to break down the squared bracket. And then when you break it using the law method, it will end up as this one. Okay, then the negative x squared, it will just be negative x squared. There's nothing more, it's just one term, all divided by h. Let's see what's happening. On top, the x squared cancel with the x squared, and you are left with limit h approaches 0. We are left with these two terms. If you look at these two terms, I can take out a common factor of h, and then inside you'll be left with x plus h all divided by h, and then the two h's can cancel. Limit when h approaches 0, we have x plus h. Just to fix this here, when I break down the squared bracket, I was supposed to have x squared plus 2xh. That was my mistake, 2xh. Then it means here, when I take out the common factor, I'll be left with 2x plus h, and then the h's can cancel. Means here I have 2. Then now, after simplifying everything, now I substitute my h, which we are saying it approaches 0. Then when I substitute my h, I'm no longer writing the limit. So this will be 2x plus the 0 as h, and then our answer is 2x. Then bear in mind that if I'm using the shortcut, differentiating this using the shortcut, I will take the 2, multiply it in front, and then I will get what? 2x. And then when I minus the 1, then I will just get 1. So you can always check whether your first principle is correct by using the shortcut. I'll be doing more example on first principle on the next video.